John. So thank you all for joining Delta Qual 2.0 kickoff webinar. And for those of you that are familiar, some of these things might be something you're used to at this point, but we have a chat feature and a Q&A feature in the Teams webinar here. If you have any questions as John's walking through this, please submit them through either one of those. We will answer you in the chat if possible. B, somebody might interject and answer that quickly for you, or we'll have a little bit of time here at the end of this to actually review all of the Q&A and have some open dialogue. So at the end, there will be an opportunity for folks to come off mic and have some dialogue with John and the team here. So with that, I'm going to go ahead and hand it over to John Martin here at America Makes to talk about Delta Qual 2.0. So John, take it away.
All right, thanks, Zane. Thank you everyone for joining us. So we just announced, I think it was yesterday, a couple more project calls. So one being Delta Qual 2.0, and then the other one, Gotham, focused on high strength aluminum, which we'll do the kickoff on that following this one. So right now we want to go over our latest project call, Delta Qual 2.0, and I'm going to get into that right now. In the background, similar to some of the other ones, this was deemed a high priority by the Joint Additive Manufacturing Working Group, or also known as the JAMWIG, which sits inside the Department of Defense under OSD, but it's comprised of various DoD, SMEs, and AM users to collaborate on potential solutions of additive and how that can help the Department of Defense. So a big focus has been on laser powder bed fusion. So that's what this project call is focused on. And just a quick overview, it's looking at 3 topics, which I'll get into. But overall, this project call is meant to enable faster and lower cost qualification in the long run. So some of these studies are going to be designed to enable that moving forward, looking into some things that I think a lot of the AM community has been bringing up for a long time. Some more fundamental aspects of the machines, understanding it a little better, how they function, operate. Not as maybe exciting, I guess, or marketable, but it's getting a fundamental, more of a fundamental understanding of the equipment. So some of the things that'll lead to is understanding the machine capability, the subsystems, measuring the subsystems, how to do that consistently, and how that rolls into what that would, I guess, help substantiate a newer framework or a more robust framework for installation qualification. And then taking a look at process windows. So opposed to, which would be the topic 2 focus, but opposed to just finding a parameter set, optimizing it for what you're going to use it for different parts that you're going to print based off of, coupon examination, and then as you get into the PQ phase, more part specific and performance specific attributes, and maybe refining your process parameters. But really, your process parameters are going to fall within some sort of window. Where they sit in that window, maybe we don't always necessarily know, but we know that it's in there, and the things that we're doing are acceptable, and the rate of production's good enough, making money, and the parts are coming out good. But would it be useful? Well, I think so, but to understand the process window itself, and instead of saying I fall within the process window, trying to figure out what is the process window, at least one that's narrow enough that we can use it to operate within. and say that that whole entire window is qualified. And then topic 3 is going to be red team, oversight team. So this project is Delta Qual 2.0. It's different than the original Delta Qual. Delta Qual 1.0 was focused on novel efforts for OQ primarily, but looking at requal things with requalification, slightly changing the process. What is that? How how in depth do we need to get with requalifying a system or making major changes to a existing qualified process? What does it take to kind of requalify that? But Delta Qual is not just for requalification. It's encapsulates anything that would kind of deviate from a traditional qual. So um, this one is going to be focused on the elements that I was just describing, but looking at them a little more prescriptively. Topic 1 is focused on aspects of installation qualification, but it's not literally like doing an IQ. It's going to be studying a machine basically that's already went through an OQ essentially, but understanding the subsystems, the operating elements of that piece of equipment to a point where you can go and do an IQ and have, I guess, more, if you want to call it front-loaded IQ, I think is one of the ideas or one of the thoughts, but more emphasis is put into the IQ. So then when you go do your OQ, it makes that easier, obviously, and then that would make your PQ hopefully easier as well, depending on what you're printing. But the whole point is to get that foundation or that fundamental understanding of that piece of manufacturing equipment that you're using, how it's interacting with your material or your family of materials, depending on how your manufacturing approach is and how well you understand that, and then getting a really good understanding up front, and then you'll have less headaches to deal with down the line. Topic 2, looking at what's being called a bracketed qualification. So finding out that qualified process window, defining it, validating it, and then topic 3, red team, which is going to have an EWD aspect to it, or an emphasis to it, which I'll get into a little later. One thing I want to make sure to mention is the material selection for topic 1 and 2. So we're leaving it open, kind of. So, but I want to make sure, and this is in the RFP, but I want to make sure I have a chance to kind of explain it a little bit, is we want, and I think maybe you can imagine just from a practical point of view, if you're going to sit there and study a printer or any piece of manufacturing equipment, you have to have like some sort of controls on your variables in your experiment. So we want the material that's being printed to be pretty well understood. But so it does, we don't really want to be using a powder that's not widely matured, because then that'll introduce unknowns that we don't that could get intermingled with how the variations of the machine might be operating. We don't want that. However, we don't want it to be Ti-64 or LC10 mag. Main reason is because we also want to leverage or take the opportunity of these projects to generate data on material that has not already been done, specifically on our end with Ti-64 because of like JMAD primarily, but some of the other projects, Delta Qual 1 was focused on Ti-64. So we want to leverage this opportunity to start, because we know that material data is going to be coming out of this, even though it's not, it's not a focused on allowables generation, but there will be a lot of material data that the community can leverage and use. So that's why we don't want to have Ti-64, and then LC10 mag is just, been a lot of investigation and studies have been done on that as well, and a lot of efforts and funding have been geared towards other types of aluminum. So this can be different types of material, but something that is very mature. So like I said, the idea is like the OQ process would not be some sort of like novel thing or an unknown journey, especially by the project team. Like this would be a material um, and a process that would be pretty familiar because we're investigating, okay, let's get down the weeds and the nuts and bolts of how this manufacturing process works and what kind of is affecting our process potentially and understanding that, how to measure it. So, topic one, the official title is quantitative measurement based installation qualification. So, literally, a very literal title. So, what we're trying to do is quantify the subsystems, how they behave, how repeatable they are, and basically getting in and looking at what we would consider the KPVs, although maybe we have too many of them identified or listed now. I think that's what one of the outcomes of this study is going to be, is better understanding the existing KPVs, the perceived KPVs, and which ones are actually key. Because I guess one way to look at it too is if you have something that's identified as a KPV, but it doesn't really, like, once you have it defined with your parameter set and your process is running fine, if it doesn't tend to drift and it's highly stable over time, yes, it's key initially, but then if it's not really going to change over time because whatever that subsystem's so robust, or it's just not, it just doesn't tend to change over time. Um, it doesn't really need to be tracked as closely compared to some others, or it wouldn't have as much of a, I guess, call it drastic effect on the outcomes of the printed material. So investigating things like that, basically trying to get information too, in regard to, if we think of things like preventative maintenance schedules, instead of just arbitrarily saying, well, we're going to do a requal every 6 months or a year, or we'll just, spot check, which I think you probably always do, but, do some spot checks of your printed parts, witness coupons. I think I don't know, personally, I guess that's pretty common in traditional manufacturing. So I don't necessarily see an issue with that, but trying to limit those things, trying to limit the material testing, the material characterization once you're in the full production mode. So once you go through your qualification event, think of kind of, I guess, watering that down and using that for your quality control. You don't want to have to keep requalifying or using too many elements that would be done in your initial qualification event. For installation qual or operational qual, this is meant to benefit all that and make it more streamlined, more affordable, and then get consensus too from the community. So print houses, service bureaus can leverage it. Customers would be comfortable with it because it would be, more of a widely known, accepted process. So that's the primary takeaway from this. Also leveraging existing standards, and then taking lessons learned, how those can be, potentially used to update some of the standards. But if we look at the EWD portion from this topic, this is going to be kind of unique, I guess, for this project call. So it is, it is focused on R&D primarily, but there's it was identified a while back that laser and optics training is a necessity. This needs to be more well understood and disseminated throughout the community within laser powder bed fusion. Understanding the laser component in general. The laser industry, as you're all, I'm sure, well aware, is its own thing. It's very large. It's used by a lot of different stakeholders within manufacturing and outside of manufacturing. And I think to start to pull some of those elements into the additive community a little bit, understand that a little better, and then disseminate that. So that's going to be one of the main deliverables coming out of this as well, is not only understanding and developing a laser optics training for laser powder bed fusion, but then um, going to a few different sites and employing that training. So working in combination with the Red team and the American Makes EWD team to develop that training material. So we think this is like a perfect opportunity to investigate that and to help pursue that EWD and really tie those two different worlds together. In our case, the pillars, right? So we have technology pillar, and one of our other pillars is EWD, and then the third is industrial based integration. But tying that together, taking the opportunity to do that with this topic is a good fit. So last at the bottom, last bullet point, one thing I want to make sure to mention as well for topic one is you need to have, so for this topic, you need to have at least 3 laser powder bed fusion systems. 2 of them need to be the same make and model, and then one that is not. And that's basically, and then you could have other printers, you could have more printers, you have different types of printers, but at the core, you need to have that. You need to have at least 3 printers, 2 that are the same make and model. Reason being, is you're going to have 2 that are highly, I'll call it referenceable to each other. So you're not, you just don't have like 6 different OEM printers, and there's no really way to attach them back to each other if there is variance. You don't really, like I said, then you have too many variables, not enough control. So this is helping introduce some of the controls of the experiment. 2 systems, same make model, so they shouldn't vary too much. It'll allow you, hopefully give you the opportunity to start to narrow down on some of the subsystem behavior and how that carries over to the material performance, understanding that. So with the 2 identical systems, one is to remain the same. The other one is to have a change, either a software update or hardware replacement. So an example being either an identical swap or upgrade of software or hardware, basically where you're introducing a change to one of the machines. Not too drastic, but you are changing it, something that might occur in real world production environment. So what does it take then to get the machine that had the change to it back within qualification? And how do you even check it initially to see if you do need to requalify it? Is it necessary to requalify? If it isn't, how do you even know that? And then if it is, how much work do you need to do to get it back into a state of qualified operating conditions? So understanding those different scenarios, and then having another machine that's different, just as to see the track the variance with that as well. So if we go on, let me double check here. So I think, well, yeah, a couple other things for topic one. NIST traceable calibration. So, and where it's not available or where you can't do it, or there's no standard way of doing it, to identify that, document it, and then recommend some way of doing it. So a lot of this is to be directly incorporated into a production environment, essentially. So giving the community like the tools or enabling them to adopt some sort of framework to do this. But to be able to do that, the calibration, the measurements, it all has to be very, very precise, at least initially. And then, as this gets adopted, hopefully, and disseminated, that can be lightened. But all the initial baselines that are done on this project, they need to be um, highly traceable. All right, so topic 2 is the bracketed qualification. Now let me go back to topic 1 real quick. I want to make sure I mention a couple more things here. So I mentioned the preventative maintenance schedule. So it's, like I said, it's installation qualification, but not like you're literally doing one. It's meant to empower that, but it's also meant to help with requalification afterwards, with changes, similar machines, and then preventative maintenance schedules to keep your machine in a state where it's essentially qualified, so you don't just kind of wait until something bad happens or obvious, or just having to do like kind of a full requal every so often. Um, some of the deliverables, so measurement based IQ framework and draft standard training materials for the optics laser training, specifically working with the EWD team, and then a cost benefit and risk analysis versus traditional qualification. So one of the big things too that we want to understand with topic 1 is, what is the risk of doing this? So say, I don't know, this project works out great and everybody's happy, but then if people start to use it, um, what are some of the risks associated with it? If say this approach wouldn't work, what are the probabilities of that happening? So understanding kind of, what somebody would getting themselves into, the risk that they're taking on looking at these new approaches. So we don't want to be too optimistic. So if we look at topic 2, this is bracketed qualification for laser powder bed fusion. Similar approach. I'm not super familiar with it. Some of you probably have seen it before, but I think it's in, I know it's in ASME, it might be in AWS as well, but they have some, it's a form of bracketed qualification, or maybe it's more material allowables or properties. But they use like a bracketed framework. But this would be more of, for the process window itself would be bracketed. So you'd have a qualified bounded space defined by your process parameters. So one of the major goals of this is to allow processing parameters to be changed to any value within a qualified range without requiring requalification. So this could be for various reasons. If we're doing a little more forward thinking, then what this would allow is to tailor your process parameters spatially throughout the part. And that could be used for a lot of different reasons. But even if we're saying we want to have the same or close to the same microstructure across the whole entire part, well, then obviously, if you use the same process parameters on one type of geometry compared to another that's completely different, these geometric features, you're probably going to have different microstructure, and it's not done on purpose. It's just because your parameters are locked in. So even if we want to not even tailor the microstructure, but just keep it consistent, we would need to float around the process parameters a bit, but you can't just do it arbitrarily. So to have a bracketed qualification approach, that would basically provide guardrails to let you know that you're operating within that window. So that's not a focus of this project, is to be able to purposely optimize your parameter sets spatially within a part for different locations that are more high critical, or you're trying to tailor microstructure or anything. I think this would enable that. One of the big things though is dealing with just your process over time, dealing with process drift. Well, how much does it have to drift where it actually is a problem, instead of, once again, maybe playing it overly safe where it triggers a requalification, and we really don't know where it's at within an acceptable process window, or what could potentially be a qualified process window, because we just don't understand it. So this is a newer approach. This is a different approach that would just give more leeway, I guess, in your operating conditions, and allow a little bit for process drift, and really exploring what is okay, what is not, and having a better understanding of all that. So um, basically what it would be is you'd have your parameter sets that, your laser power, scan speed, different things like that. And then you would get, this is just an example, but we want the proposers to, tell us the best approaches they think. Um, is you would track that with things like maybe cooling rates or interlayer temperatures or something like that. As some sort of, so it's not focused on in situ process monitoring, but it would rely on elements of that, but they'd all have to be direct measurements, and be able to be, calibrated, traceable if possible, where not, identified and spec'd out and proposed how someone would do that. Um, but basically, tracking your process, how that correlates to your process parameters, and then basically you're tracking your process, understanding, say, your cooling rate is being produced by whatever process parameters you have, and then it'll change depending on your process drift. Um, how much is okay, and that would be from tracking things, and cooling rate is one of the examples. Tying back to things like your thermal history, and that are obviously critical to your part. So that's the idea of identifying an acceptable process window, or I guess more than acceptable, but one that's deemed qualified. Um, so one of the things, well, I guess I'm getting a little ahead of myself. So I'll go the next bullet down. So in addition, so the test plan. So looking at the test plans to understand or define this qualified, bracketed qualified window. So coupons will be used, and what they'll be used for is basically to understand where the window is, but not just what we want to understand the inside of the window, obviously, and then the outside of the window. So understanding things beyond just what is acceptable or what is deemed qualified. I suppose you could even have like an acceptable window and then shrink that a little bit and say this is qualified. However, somebody would want to set that up, but the point is to have an understanding of not just the parameters that are giving you good material, but the parameters that are giving you, um, maybe material that seems good, but it's not good enough and wouldn't pass inspection at the end of the day. Understanding where those boundaries lie, and where how much padding do you have to play with in different areas, and what parameters are going to affect that more, and understanding, things like gas flow, and laser power, and just things that can potentially change over time, and how those could be measured, and then deemed acceptable with the drift that might be associated with those over time. So developed framework should not rely upon in situ process monitoring, closed loop control methods to actively modulate the processing parameters. So this is when establishing the acceptable inner bounds, outer bounds of the bracketed qualification. So that's important to mention. So it's not like you're just using, AI, ML, in situ process monitoring, and different digital techniques to just define a bracketed qualified window. So it's really the bracketed qualified window is going to come from just good old fashioned printing stuff with different parameters, understanding where those boundaries lie, leveraging some of these more advanced tools in addition while you're developing it. If you want to, teach them or better understand, obviously, things like your interlayer temperature or cooling rate, you're gonna have to do that anyway. But then once it's being tracked, you would incorporate those things more like the in-situ process monitoring. But to develop it, it's more going to be experimental. Like, here's my parameters, here's what my coupon, say my tensile test or whatever different test you're doing, porosity, density. Here's what it looks like, and how many coupons you need to do that. So we're not looking at doing a ton of coupons, but whatever it takes, right? So you want to be efficient with it. The teams are encouraged to try and use more machines opposed to just printing more coupons on a fewer number of machines. But at the same time, you will need enough material property data at certain parameter sets to just get that correlation of what the material is going to look like out of the printer with certain types of parameters. So the teams shall develop a validation testing matrix to demonstrate performance within, at, and beyond the edges of the defined manufacturing window. So that's important. Oh, and then also, yeah, the MMPDS CD basis allowables or similar required, not preferred. So this is important as well. So this is not to develop a allowable data set, but we do want to leverage an allowable data set if it's in existence for the material that you choose. I doubt by the time, it'd be published in MMPDS, but something along those lines, or is in the process of going into the handbook or exists in another handbook or another data set that's out there, that, a member would be willing to share, I guess, but something that has to be used as benchmark reference data beyond what is being originally produced in the study, but the focus and also the desire of the output is not an allowable data set. So it should be less than that, for sure. But we also don't want it to be, we printed, 3 tensile bars, and now we know everything about our process. So it's going to be a balance. So yeah, for topic 2, it's the description's written in a paragraph form, and then it's followed up by a bullet list because there's kind of a lot there. It makes sense, but it's kind of hard to read, at least the first time through. The red team. So the red team is going to be similar to what we've had other red teams for. We had a red team on Delta Qual 1. We've had a red team on some other projects. So this is going to be basically an advisory team. It's going to be comprised of industry, academia, and government subject matter experts and stakeholders. And the idea is to help coordinate the teams on 1 and 2, but also to make sure that all the work that's being done is going to flow and transition into DoD needs, industry needs, as good as possible, that we don't start, going down, whatever you want, going off in the left field a little bit or something with some of these things. So to keep everything kind of harmonized on track and to serve as, provide a perspective of the performing teams from various different vantage points of saying, this is important. This is what we need. Maybe focus on some more of maybe certain types of process parameters and others. So providing key input like that. So the red team, whoever's going to be the red team, is going to be working in conjunction with a team of U.S. government stakeholders. So this is a little nuanced, I guess, but the red team will have some government stakeholders on it, but there's also going to be a separate government stakeholder advisory, just government only advisory team for this project as well. So there's going to be both. The red team is going to be competed, funded. The advisory team on the government side, primarily, I don't want to say it's going to be just out of the GMWIG. It's going to be identified by the GMWIG, but it's going to be government only folks tracking the project, providing input, feedback, stuff like that. So yeah, define and evaluate key performance parameters. I don't know if it's explicitly spelled out to define, might be in the RFP. But at the end of the day, they have to, whatever KPPs are proposed or, going to be considered by topic PIs or performing teams for topics 1 and 2, they would need to be, they got to work with the red team. So they might need to be adjusted or some additional ones taken on. Looked at and reviewed 3 times per year at a minimum, and then organize a review at least 3 times per year. And then we're going to be tracking lessons learned. So that's become common on a lot of our projects, but for this one especially as well, red team tracking that, cataloging that, and organizing that. So another thing that looking out of the red team is to provide input and recommendations to the SDOs, the certain committees within the SDOs, to consider including some of the information we find from this program, more awareness that they know. There might be some new approaches that come out of this. So we want to make sure that that's all coordinated, disseminated out to the appropriate folks within the AM community. So obviously standards being very important. And the red team obviously is going to have special emphasis with topic area 1 team. There'll be 2 teams on there. The American Makes EWD team to develop that training material for the laser optics training, and then also deliver it. And I believe it says in the RFP, but I think it's maybe 2 training sessions. All right, so if we look at the funding breakdown and award number breakdown, so topic 1, which is focused on the subsystems, understanding the subsystems, there's going to be 2 awards, each award up to $2.7 million. Topic 2 for the bracketed qualification, anticipate 1 award for that with an amount of $2.7 million. And then topic 3 for the red team, anticipating 1 award for that, and that funding amount is expected to max out at $900,000. Now, if we look at the cost share requirement is 50% just for topics 1 and 2. Topic 3 does not require cost share. It's highly encouraged, but it's not required. So if we look at the technical periods of performance, 24 months for topics 1 and 2, 27 months for topic 3, the red team, give them a little longer, obviously, to be able to digest everything and summarize it on the back end. So total period of performance with 3 months of reporting for each, we're going to have 27 months for topics 1 and 2, and then 30 months for topic 3, red team. So the schedule breakdown, project call was announced, I guess it was yesterday. I apologize, I'm losing track of days here. And that we're moving fast. So yeah, kickoff today. Questions from proposers. about 2 weeks from today, 2 weeks from yesterday. So you guys got, I think usually it's like 1 week from the kickoff. This one was a little quick turn. We have some schedules colliding and conflicts and things. TRX is coming up soon, by the way, a couple weeks. But questions from proposers to do April 14th. And then we will get the responses back to you 1 week after that on April 21st. See some information there for membership agreement, NDA executed with NCDMM, and then deadline to be paid in full as member. The proposal submission due date is going to be June 2nd. So roughly 60 days is what we've been trying to do for our projects. And then we plan on having a decision announced to the winning proposal teams, not a public announcement, but at least to the winners initially on July 6th. So if we look at membership eligibility, already talked about the cost share, but the eligibility, pretty standard to our other project calls. So the lead proposer needs to be a current member of America Makes in good standing and paid in full by May 18th. So that's the lead proposer only. Project team members are not required to be America Makes members, but are highly encouraged to do so. Another thing too is on, I think all the projects, is if you're not a member, I'll say you're not privy, you're not going to get like all the project information. You're only going to get what you need to perform on the project because you're not a member. So if you are on a team, it's highly encouraged. And then also, we have a lot of opportunities for cost share, going to events, working on projects. So, feel free to reach out to the Institute on different ways to leverage that. So if we look at eligibility, I mean, pretty standard here. So this isn't, this is, you don't need necessarily anything extra compared to our normal projects. So government contracting information, cage code, system for award management. Now, when we're looking at foreign nationals, so I believe it says in the RFP, it's standard language for the most part is any work being done outside the US is discouraged. So sometimes it's acceptable. Typically, if it's like you have to do it, like we're like this project, I'm just giving an example for like powder supplier or something. A lot of those are out of Europe, for specific types of material. So for this one, I don't really see that being a thing, but that does come up. And there are other instances as well to have, some people do some work outside that have a specific expertise. Always helps if it's at a, somebody like that's over in Europe or something. But if that needs to be done for your project, we need to know basically as soon as possible. That makes everything go a lot easier and keeps the proposal teams in the mix, in the hunt for being considered. So it must be reported and approved in advance by America Makes Program Management Office. So foreign nationals from the following countries, which are listed here, will be an automatic disqualification. So you can see the long list of countries on there that you cannot have project team members from, being active citizens from. And then further information, section 3.4 of the RFP. So deliverables and reporting on these sections here. So deliverables table, section 2.4, and then a list of reporting requirements towards the end of the document in section 4.3. And then if we look at the evaluation criteria, Executive summary, not scored, but basically you just want to set that up so the reviewers can kind of get oriented with what you're have laid out in your technical volume. So technical approach and methodology is going to be worth 40%. Technology dissemination and impact on the U.S. supply chain is going to be worth 30%. The program management approach is going to be worth 25%. And then the cost is going to be worth 5%. We have a full detailed breakdown of the scoring criteria, the elements that are under each one of those 4 primary categories in section 4.1 of the RFP. And then this is information on proposal and contracting information that I will not go over. And then I want to make sure that everyone is aware of our teaming platform function that we have. So if you go to the project call page, it's on all of our project calls. We started this a few months ago, or maybe longer, but yeah, apparently longer because this is from several months ago, I guess, August. Go to the program description, you see where you can download the RFP. If you look to your right, there's I'll call it, it's not a pop-up, it's just a thing that's there. Interested in teaming. So if you click on team up, then you're asked to enter some information. And what this does, I think there's another, yeah. What this does is it gets your information into the member portal, and then it allows other people to go to the project teaming, or I guess the different project call announcements, click on a file that contains your information. So what it does is it allows people to know that you're either looking to build a team or contribute to a team, what your skill set is, what you have to offer, different things like that. So it's a really nice tool for our members to quickly get acquainted. But more importantly, when it comes to running project calls, is how can I build a strong team and how can we leverage each other, and put a proposal together. So definitely want to make sure that everyone is aware of that. And that's it. So any questions?
There are a
So
few questions in the chat.
all right, yeah, I'm going to go through those. So topic 2, what range are you looking for when calling out the material qualification? Is it something like 5%, like a sensitivity analysis, or over 20%? None of that is going to be specified. So I think that's something, I guess I'll say, that would probably be good to consider when writing a proposal, but I could kind of see that being fluid as you're going through your experimentation. It's a good question, but yeah, like how fuzzy is your outer window, your frame of your window, how fuzzy is that going to be, I guess, is kind of the point of that question. I don't know, but yeah, that would be good to capture for sure. But I think, like I said, I think that's something that would probably, you know, change and you wouldn't know for sure until getting quite a way through. And hopefully you can get it to a point where it's pretty well defined. Topic 3, is there a recommended team composition? Example, number of members, proportion of academia, industry, government. No, there's not. What I would do for this, if I was interested in this, is I would look at other American Makes projects that we've had in the past and other red teams that we've had. So like I said, we had one for Delta Qual 1.0. We have one now for Q time, although I think it's called like industrial transition team, I think, something like that. But basically, same idea. And then I think we've had some other projects too that have had some red team elements to it. So I would go refer to that. But now, really, what we're looking for the proposers to, offer to us what they think is a good composition of a red team from our members. So next one for topic 2, do you envision the use of computational simulations to reduce physical testing? Great question. So this is in the RFP, it's mentioned. The teams are encouraged to use those tools, but is definitely not required, and it's definitely not an emphasis. So if you are going to use them, it would be more supplemental support. It would not be the emphasis. That's for sure. But yeah, leveraging digital tools to increase efficiency is typically encouraged. However, we don't want to conflate or lead people to think that if you got a really great method for computational simulation that you could just like really leverage that for this project. It's not what the focus of this project. So it can be used, but definitely not the emphasis. So yeah, copy of the presentation that'll be posted on the website after. Well, the presentation might already be up, and then we'll have a recording of this as well. Yeah, okay. So Zane put that in the chat. And then, given that Tie 6.4 is not allowed, are there alloy systems that are preferable, or does it not matter? So that's a good question. I don't want to say any because that would just be literally like my opinion, not even my opinion, just like an alloy that just popped in my head on this call. So I don't even want to give any examples, but I'm sure, probably a lot of you are thinking of the same one I'm thinking of now. Not that, so I don't, it's not like if you pick the right one, it's like, yay, you're gonna win necessarily, or probably has anything to do with that. But what you do, you want to make sure it's a material that we in a process, so in this case, a laser powder bed fusion machine, in a material that's pretty mature, pretty well understood, because we don't want any mysteries or variables that are going to be buried within that material process combination to be getting intermingled with the project team trying to just understand subsystem performance from the printers. Like that's one thing we're not going to be able to fully eliminate it, but we want to get it out of there as much as possible. So it's going to have to be a material it's not going to be like anything cool or novel or not even close to that. It's going to have to be something that's less exciting, but would also be beneficial to the community as well. But there's different ones. I guess I would say I would offer up, just look at some of the materials that are being used by the different services. I know Navy's doing a lot of work. Air Force, obviously, some of the stuff Army's doing. I don't even know, honestly. I think that would, that helps, obviously, but it's really just to make sure that the material is pretty well understood, whatever is chosen. All right, another question. I joined late, so sorry if explained already. Can you provide background for the exclusion of Tie 6.4 and LC10 mag? Assume other aluminum alloys still could be of interest. So yeah, because the Tie 6.4s, we've done a lot of work on that already. So I think it's just taking the opportunity to generate material data for something else besides the Tie 6.4, since we did so much work with it on JMAD and Delta Qual 1, and then now it's 10 mag. I think it's just so there's other aluminums, as long as they're mature. Yeah, those could be of interest. But it doesn't have to be aluminum, it could be anything. And then for topic 2, Do you also want proof on multiple machines brands? Yes. So in the RFP, it's mentioned in the deliverables that this needs to be demonstrated on another platform. So yeah, great question. Um, Topic 1 and 2, the data-driven AI ML methodology proposals are acceptable. Well, I guess that kind of same vein as the computational, simulation. Um, definitely, definitely not an emphasis. So that would be more of just kind of ancillary, supplemental, if you want to say nice to have. I think it would be great to incorporate it into all this, because that's where things are ultimately going to have to go. But we want this foundation to be based off of things that we've been doing for a long time and we understand very well. Once again, to avoid just introducing variation and very unknowns into the experiment, that we don't really know that well. And then, should the material chosen be one that has or can have statistically valid material allowables? I think that would help for sure. And that would be good to point back, especially I think it was topic 2. I don't know if it was in the slides, but it's in the RFP of doing like a baseline check of like, okay, what is the risk? What is the probability? If this material starts to drop below, like the material properties start to drop below a known allowable data set, such as MPDS or something that, would be similar depending on whatever material you choose. When is it going to go below that well-known threshold that exists out there outside of just the data that's been generated on this project? Like there has to be some other data that's being referenced to for the material performance and behavior. Does it have to be an MMPDS qualified material? No, it is not. Yes, thank you, Doug. Yeah, there's only one so far. All right. So that's all the questions I see in the chat. Hopefully that's all because we only have 2 minutes left and we got another kickoff. So thank you everyone for joining. Zane, I don't know if you want to close us out or I could do it, I guess.
Yes. So sorry.
No, you're good.
So yeah, no, thank you all for joining us. We are going to be shifting over to the Gotham Project Call Kickoff webinar. If you have not registered for that, I will leave the link to register in the chat, and please try to hop over as quick as possible. And on that call, John, for your heads up, we will also be having Evan and Kyle join us.
Okay, good. Yeah, thank you for the heads up.
Thank you all, and we will see you at the Gotham Project Call.